Based on the like and unlike fractions, let us look at some questions. Question number 1. Show 2 by 6, 4 by 6, 8 by 6 and 6 by 6 on the number line. So how do we represent these fractions on the number line? Now, in order to represent anything on the number line, we focus on the denominator first. Right? So once we focus on the denominator, so the denominator in this case is 6. So the denominator this case is 6. Therefore, we will divide each block into 6 equal parts. So, let's say this is 0, this is 1, this is 2, this is 3, 4 and so on. So, we will divide each block, that means this is one block and we will divide it into 6 equal parts. 1, 2, 3, 4, 5 and 6. So, this becomes 1 by 6, 2 by 6, 3 by 6, 4 by 6, 5 by 6, 6 by 6. Similarly here 1, 2, 3, 4, 5 and 6. So it has not come very equal, but that's okay. 7 by 6, 8 by 6, 9 by 6, 10 by 6 and so on. So now we have to represent 2 by 6. So this is 2 by 6 here. 4 by 6. So 4 by 6 is here. 8 by 6. 8 by 6 is here. And 6 by 6. 6 by 6 is nothing but 1. So this is here. So in this fashion, we can represent all of these on the number line. Now, looking at their positions on the number line also, we can say that 2 by 6 is lesser than 4 by 6, which is lesser than 6 by 6, which is lesser than 8 by 6. Question number 2. Compare the fractions and put an appropriate sign. 1 by 7 and 1 by 4. So how do you compare these two? So they have same numerator, different denominator. Which has greater denominator? 7. Therefore 1 by 7 would be lesser. 4 by 5, 5 by 5. They have same denominator. So compare the numerator. 5 is greater than 4. So 5 by 5 is greater than 4 by 5. 3 by 6 and 0. Which is greater? So obviously 3 by 6 would be greater. That's because any positive number is always greater than 0. So this would be greater. 5 by 6 and 5 by 5. Here again same numerator, different denominator. So 6 is greater than 5. So 5 by 6 would be less than 5 by 5. 2 by 4 and 3 by 6. So in this case, they are completely unlike fractions. Denominator is different, numerator is different. So let us try to compare them. So 2 by 4, if you bring it to its simplest form, it becomes. So 2 by 4, if you bring it to its simplest form, it becomes 1 by 2. 3 by 6, if you bring it to its simplest form, it becomes 1 by 2. So that means both of these are equal because they are nothing but equivalent fractions. Question number 3. Ela read 25 pages of a book containing 100 pages. So that means out of 100 pages, total number of pages in the book was 100 and number of pages that Ela read was 25. Okay, so this is the case of Ela. Now we have another girl named Lalita and she read 2/5 of the book. So who read less? So for that we will have to find out the fraction which has been read by Ela. So Ela read 25 pages out of 100 pages. So 25 by 100. So if you find out the HCF of 25 and 100, the HCF comes out to be 25. So therefore in the simplest form it becomes 1 by 4 because you divide the numerator and the denominator by 25. So Ela read 1/4 of the book and Lalita read 2/5 of the book. So how do you compare these two? How do you compare which is bigger? So for that what we have to do? We have to find the LCM of the denominators. That is, you will have to find out LCM of 4 and 5, which is 20. So now we convert each of these fractions into a form such that the denominator is 20. And we do that for both the fractions. So what is that number which you need to multiply to 4 so that you get 20? You multiply it by 5. So you multiply the numerator also by 5. So you get 5 by 20. Similarly, what is that number which you multiply by 5 to get 20? That is 4. So you multiply the numerator also by 4. So it becomes 8 by 20. So now you can compare 5 by 20 and 8 by 20, which is smaller. 5 by 20 is smaller and 5 by 20 is equivalent to 1 by 4. So 1 by 4 is less than 2 by 5. Who read 1 by 4? It is Ela. So who read less? Ela read less. Question number 4. In a class A of 25 students, 20 passed in first class. In class B of 30 students, 24 passed in first class. In which class was a greater fraction of students getting first class? So let us look at the fraction of students getting first class in class A and in class B. So in class A, how many students got first class? So fraction of students getting first class is 25 students. 20 students got first class out of 25 students. So 20 by 25 is the fraction of students who got first class. Similarly, in class B, 24 students out of 30 students got first class. So the fraction is 24 by 30. So we have to compare which of these fractions is bigger. So for that, let us first try to represent each of them in their simplest form. So for that, let us first write down the factors of 20 and 25 so that we can find HCF. So the factors of 20 would be 1, 2, 4, 5, 10 and 20. And for 25, it would be 1, 5 and 25. So the highest common factor would be 5. So HCF would be 5. So let us divide the numerator and the denominator by 5. So divide the numerator and denominator by 5. You get 4 by 5. Now let us do the same thing for class B. So in this case also, let's find out the factors first so that we can determine the HCF. So the factors for 24 would be 1, 2, 3, 4, 6, 8, 12 and 24, and the factors for 30 would be 1, 2, 3, 5, 6, 10, 15 and 30. So which is the highest common factor? So the highest common factor would be 6. So that is HCF is equal to 6. So what do? We divide the numerator and the denominator by 6. So you get 4 by 5. So what did you observe? You observe that both of them actually represent 4 by 5. That means 20 by 25 and 24 by 30. These are equivalent fractions. Therefore, in both the classes, same fraction of students got first class. A pizza was given to two friends, Rohan and Amit. And they divided the pizza into 8 equal slices, and then Rohan had 2 slices out of those 8 slices. So basically Rohan had 2/8 of the pizza and Amit had 1 slice of that pizza. That is, Amit had 1/8 of the pizza. Now both of them are very much interested to know that what fraction of the pizza did they eat together. So together how much did they eat? So Rohan ate 2/8, Amit ate 1/8. But in order to find out how much did they eat together, we actually need to add 2 by 8 and 1 by 8. So in this section, we are going to learn about addition and subtraction of fractions. So first let us deal with addition of fractions, and in that also we will first take up simpler ones, that is the like fractions. So how do we add like fractions? So how do we add like fractions? Again, whenever we deal with like fractions with same denominators, things are pretty simple. So all we need to do is retain the denominator. Let us suppose these are the two like fractions that you have. Let's say 3 by 5 and 16 by 5. So these are the two like fractions which needs to be added. So what we do, we retain the denominator. So the denominator in the result is also going to be the same, which is 5. And then what we do, we just add the numerators. So 3 plus 16. So 3 plus 16 is 19 by 5. So 19 by 5 is the sum of these two fractions. Let's take one more example. 13 by 101 plus 5 by 101. So how do we add these two? So denominator remains the same. Add the numerator. So 13 plus 5 is 18 divided by 101. So in this fashion, we can add the like fractions. Now, what about subtraction of like fractions? That is also going to be on the same lines. So in this case also you retain the denominator, but this time you subtract the numerators. So let's take example. 3 by 5 minus 1 by 5. So you retain the denominator and you subtract the numerator. So this would be 2 by 5. Similarly, 13 by 101 minus 5 by 101 will be equal to 13 minus 5 divided by 101, which is equal to 8 by 101. So it's pretty simple, right? So as I said, that like fractions are pretty simple to handle. So how do we add the unlike fractions? Now this is not that simple, but not that complex as well. So here you are going to have different denominators. So let us take an example. So let's say you have one fraction 1 by 5 and you have other fraction 3 by 7 and you need to add the two of these. So what will you do? First of all, you will find the LCM of the denominators, because in this case also our approach is the same. Whenever you have two unlike fractions, you want to compare them, first convert them into equivalent fractions. You want to add them, convert them into equivalent fractions. You want to subtract them, convert them into equivalent fractions, such that the equivalent fractions have the same denominator. So that is our motto all the time. So in this case also, let us find out LCM of the two denominators. So LCM of 5 and 7 would be 35. Okay, so now our aim is to convert 1 by 5 into a form such that the denominator is 35. So for that you multiply 5 with 7. So you multiply the numerator also by 7. So you get 7 by 35. Similarly, for 3 by 7 also you need to multiply with such a number so that the denominator is 35. So you multiply it by 5. So you get 15 by 35. So now this can be written as 1 by 5 can be written as 7 by 35 and 3 by 7 can be written as 15 by 35. So therefore, how much do you get? This is adding like fractions. So 15 plus 7 divided by 35, which is equal to 22 by 35. So in this fashion, you get the sum of two unlike fractions. So this is also not complex. It is just that you need to convert the two unlike fractions into equivalent fractions such that the equivalent fractions are like fractions. Now let us look at the subtraction of unlike fractions, which is also going to be on the same lines. So 13 by 8 minus 1 by 9. So how do you subtract these two? So let's find out the LCM of 8 and 9, which is 72. So 13 by 8, you have to convert it into a form with denominator 72. So you multiply 8 by 9. So you multiply the numerator also by 9. So you get 117 by 72. Similarly, 1 by 9, what is that number which you will multiply so that you get 72? You multiply it by 8. So numerator also by 8, so you get 8 by 72. So 13 by 8 can be written as 117 by 72. 1 by 9 can be written as 8 by 72. So this is 117 minus 8 by 72. This is equal to 109 by 72. So now that we have discussed both like and unlike fractions, how do you think we will add mixed fractions? So we have already discussed about mixed fractions, right? So mixed fractions have something very interesting. They have the whole number part as well as the fractional part. Something like 2, 3 by 4, 1, 1 by 3. So these are all mixed fractions. Now if you have to add two such mixed fractions, so how will you add them? Because in that case, just by looking at them, you will not know if they are like fractions, if they are unlike fractions. Even if they are like fractions, you do not have just one denominator. You also have the whole number part. So how do you handle all of that? So let us look at an example. Now there are two different methods of adding mixed fractions. So now we will discuss the first method, method 1. So in method 1, what we do is, whatever mixed fractions are given in the problem, we just convert them in the form of improper fractions. Because by now we all know that mixed fractions are nothing but they are improper fractions which are expressed in a way such that there is a separate whole number part and there is a separate fractional part. Otherwise, they are improper fractions only. So let us take an example. So the first example, we take 2, 3 by 4 plus 1, 1 by 4. let's say that you have to add these two mixed fractions. So what you do, you convert this into improper fraction. How you convert into improper fraction? Remember, mixed to improper, you have to remember MAD. First multiply, then add. So you go like this, multiply, then add. So 4 2s are 8, 8 plus 3, 11. So this is 11 by 4. What is this? 4 into 1, 4 plus 1, that is 5 by 4. So it is 11 by 4 plus 5 by 4. So these are like fractions again, same denominator. So you just need to add the numerators. So this is 16 by 4. So this would be the answer. Let's take another example where we deal with unlike fractions. For example, you have to add 2 3 by 4 with 1 1 by 5. So now you have different denominators, right? So they are unlike. But still, let us convert them into improper fractions first. So 4 into 2 is 8 plus 3 is 11. So 11 by 4 plus 5 into 1 is 5 plus 1 6. So 6 by 5. So in this case, what would be your next step? So next step, we will find out LCM of 4 and 5, which is 20. Now once we have found out the LCM, our job is to convert each of these fractions into equivalent fractions. So we have to convert 11 by 4 into a form such that the denominator is 20. So for that, we multiply the numerator and denominator by 5. So you get 55 by 20. For the second case, 6 by 5. Again, you multiply the numerator and denominator by 4 so that you get 24 by 20. So now 11 by 4 can be written as 55 by 20 and 6 by 5 can be written as 24 by 20. So this becomes 55 plus 24 divided by 20. So 55 plus 24 is 79 by 20. So 79 by 20 would be the sum of these two mixed fractions. So this was the first method where we just write the mixed fraction as improper fraction and then we do the addition like how we do for like and unlike fractions. Now what is the second method of adding mixed fractions? So let us have a look at this method. So in this case, we add the whole parts separately and the fractional parts separately. That's again interesting. So let's take an example. Let's say you have to add 2 3 by 4 plus 1 1 by 4. So which is the whole number part? So this is the whole number part for this mixed fraction. This is the whole number part for this mixed fraction. So we add the whole numbers separately. That is 2 plus 1 is added separately. And the fractional parts, that is 3 by 4 and 1 by 4. These are added separately. So 2 plus 1 is 3. 3 by 4 plus 1 by 4 would be 3 plus 1 by 4. So this is equal to 3 plus 4 by 4, right? So 4 by 4 is 1. So this becomes 3 plus 1. So this becomes 4. So 4 is the answer. So this is one way of adding the whole part separately and the fractional part separately. So in this case, you do not convert it into improper fraction. Let's look at another example. Let's say you have to add 2 3 by 4 plus 1 1 by 5. So how do you add them? Again, pick the whole numbers which are 2 and 1. So 2 and 1 to be added separately and 3 by 4 and 1 by 5 to be added separately. So 2 plus 1 is 3. And how do you add these two? They are unlike fractions. Do you take the LCM? So LCM of 4 and 5 is 20. So the denominator in the result would be 20. Now if you convert this into like fraction, you have to multiply 4 into 5. So when you multiply 4 into 5, so 3 also you will have to multiply by 5, so you would get 15. In this case, 5 into 4 would give you 20. So in the numerator also you will multiply by 4. So this would be 4. So this becomes 3 plus 19 by 20. So now when you add these two, so how do you add these two? Again the same thing, because both of these are unlike. So here 3 is like 3 by 1 plus 19 by 20. So you would follow the same technique where you take the LCM of 1 and 20, which is 20, right? So 1 into 20 would be 20, and so you multiply 1 by 20. So this also you will have to multiply by 20. So you get 60 plus, in this case it would be 19, because 20 into 1, so 19 also into 1. So basically I am converting it into equivalent fractions, right? So instead of doing it separately, I am just doing it directly here. If you want, you can do it separately first. The 60 plus 19 would be 79 divided by 20. So this would be the answer. We will solve a few questions. Question number 1. Sarita bought 2 by 5 meter of ribbon and Lalita 3 by 4 meter of ribbon. What is the total length of the ribbon they bought? So Sarita bought 2/5 and Lalita bought 3/4. So total how much did they buy? So total would be 2 by 5 plus 3 by 4. Now these are unlike fractions. So what would you do? You will take LCM of the denominator. So LCM of 5 and 4 would be 20. So now we convert each of these fractions into an equivalent fraction such that the denominator is 20. So for that you need to multiply 5 into 4. So the numerator also gets multiplied by 4. So you get 8 by 20. Similarly, for 3 by 4 also you need to convert it into a form with denominator 20. For that you multiply it by 5. So numerator also by 5. So you get 15 by 20. Therefore 2 by 5 can be written as 8 by 20. 3 by 4 can be written as 15 by 20. So this becomes 8 plus 15 divided by 20, which is equal to 23 by 20. So the total length of the ribbon would be 23 by 20 meters. Question number 2. A piece of wire 7 by 8 meter long broke into 2 pieces. One piece was 1 by 4 meter long. How long is the other piece? So let us say this is the total length of the wire which broke into 2 pieces. One piece was 1 by 4, the other piece we don't know. So let's say that the other piece was x. So this basically means that x plus 1 by 4, that is these 2 pieces together, gives 7 by 8, that is the length of the wire. Right? So therefore x would be 7 by 8 minus 1 by 4. So from the total you subtract the first piece. So whatever will be left would be the second piece. So now you have to subtract these two. So again we will do the same thing. In this case these are unlike fractions. So let us find out LCM of 8 and 4. So LCM of 8 and 4 would be 8. So for 7 by 8 it is in the form where the denominator is 8. So it is fine. Let's convert 1 by 4 into a form such that the denominator is 8. So for that we multiply the numerator and denominator by 2. So you get 2 by 8. So 7 by 8 minus 1 by 4 can be written as 2 by 8. So this becomes 7 minus 2 by 8, that is 5 by 8. So 5 by 8 meter would be the length of the other piece. Question number 3. Asha and Samuel have bookshelves of the same size, partly filled with books. Okay, both of them have bookshelves. Asha's shelf is 5/6 full. So it is 5/6 full and Samuel's shelf is 2/5 full. Whose bookshelf is more full? By what fraction? Which is more? You have to decide whether 5 by 6 is more or 2 by 5 is more. Again, since they are unlike fractions, first we will have to convert them into equivalent fractions which are like fractions. So LCM of 6 and 5 would be 30. So 5 by 6 to be converted into a form where denominator is 30. So we multiply numerator and denominator by 5. So it becomes 25 by 30. So we do the same thing with 2 by 5. You have to convert it into a form with denominator 30. So we multiply numerator and denominator by 6. So you get 12 by 30. So now if you compare, you see that 25 by 30 is greater than 12 by 30. So 25 by 30 is nothing but it is same as 5 by 6. So 5 by 6 is greater than 2 by 5. So whose shelf was 5/6 full? Asha's shelf. So therefore we can say that Asha's shelf is more full. And by what fraction? So by what fraction her shelf is more full? So for that we will have to subtract the 2. That is 5 by 6 minus 2 by 5. Now 5 by 6 is equivalent to 25 by 30. So we can write it as 25 by 30 minus 12 by 30. So this would be 25 minus 12 by 30, which is equal to 13 by 30. So Asha's shelf is more full and it is more full by 13 by 30. Question number 4. Javed was given 5 by 7 of a basket of oranges. What fraction of oranges was left in the basket? So that means there was one complete basket of oranges. So that full basket of oranges is basically how much fraction? It is nothing but 1. 1 means one full basket. So out of this full basket, how much was given to Javed? 5/7. So how much is left? 1 minus 5 by 7. So in this case, 1 has the denominator also 1. So therefore LCM of 1 and 7 would be 7. So this 1 by 1 to be converted into a form such that you get denominator as 7. So for that you multiply the numerator and denominator by 7. So you write it as 7 by 7. So therefore 1 by 1 can be written as 7 by 7 minus 5 by 7. So this becomes 7 minus 5 by 7, which is equal to 2 by 7. Therefore 2 by 7 fraction of the oranges was left in the basket. Question number 5. Shubham painted 2 by 3 of the wall space in his room. His sister Madhavi helped and painted 1/3 of the wall space. So how much Shubham painted? He painted 2/3 of the wall. And how much did Madhavi paint? She painted 1/3 of the wall. How much did they paint together? So together they did 2 by 3 plus 1 by 3. Now these are like fractions. So how do you add like fractions? Just add the numerators and retain the denominator. So this is 3 by 3, so which is equal to 1. So 3 by 3 in its simplest form is nothing but 1, right? So therefore, we can say that they together painted the whole wall. 1 means, one fraction means the complete thing. So the complete wall was painted by Shubham and Madhavi together. So with this, we have reached towards the end of this lesson on fractions, and I hope that this lesson would have helped you. So focus on the concept, solve more questions for better understanding. See you all in the next lesson.